Now the discuss the next topic is the symmetry and the skew symmetric matrix. Symmetric and skew symmetric matrices. Now the first of all discuss about the symmetric matrix. Now if we take a square matrix, a square matrix A Aij is called a symmetric matrix. Now the condition for the symmetric matrix is, now if we change the row by the column but the result is not changed, means if we take the transpose of this matrix is now again equal to the A, so it is the symmetric matrix. Now means Aij equals to the Aj for all Ij, for all Ij. Now let's take the example of the based on the symmetry. Now if A equals to -3 -1 1 -1 2 5 1 5 -2. Now let's check the matrix is a symmetric or not. Now if we take the transpose of this matrix, then -3 -1 -1 -1 2 5 1 5 -2. So now the A equals to the A transpose, so Aij is equals to the Aj. So it is symmetry. Now it's an example of the symmetric matrix. Now next is skew symmetry. Skew symmetric matrix. Skew symmetry matrix means whose the diagonal elements are 0. A skew symmetry matrix means whose the diagonal elements are 0 and the non-diagonal elements, the relationship is like in this form. Now if the skew matrix, now in the now for the skew symmetry matrix, now A is square matrix, so A equals to Aij. Now if the A transpose is equals to the minus A. Now if the A transpose is equals to the minus A, so it is skew symmetry matrix, means the Aij equals to the minus of Aj. Now let's take the example. A equals to the 0 2 -3 -2 0 5 3 -5 0. Now if we take the transpose of this matrix is 0 -2 3, then 2 0 -5 -3 5 0. Now the A transpose is equals to the, now it's not clearly shown, now the A transpose is equals to the minus of A, because now in the matrix A, the it's a -2 and here is a 2, now it's a +3, it's a -3. So when the matrix A is multiplied with the minus 1, now is equals to the A transpose. So A transpose is equals to the minus of A. Now in the skew symmetry, now in the skew symmetry, I said the one statement. Now in skew symmetry the diagonal elements are 0. So why the diagonal elements are 0? So now we need to see. So we are proving the diagonal elements are 0. Now prove that the elements on the main diagonal of a skew symmetric matrix are all 0. So how to prove? Let's see. A equals to now Aij. Now be a skew symmetry matrix. Now if the if we find now if A is a skew symmetry matrix, so Aij is equals to the minus Aj I. Now at the diagonal elements I equals to j, 4 all I, 4 all. So ai equals to minus of aii. So 2 times of aii is equals to the 0. So aii equals to the 0. Aii means the number of row so the number of row equal to the number of column means the diagonal element. So for a skew symmetry matrix the all diagonal elements are 0. So a11 equal to a22 equal to a33 equal to ann is equal to the 0. Now let's take the next example. Let A be a square matrix. Let A be a square matrix. Then first A plus A transpose is a symmetric matrix. Second is A minus A transpose is skew symmetric matrix, and the third one is A into A transpose and A transpose into A are symmetric matrices. So now solve. So now the solution for the first part. Let P equals to A plus A transpose. So now if we find out the transpose of the P, so the A plus A transpose whole transpose now is equals to the A transpose plus A transpose of the whole transpose. So it is A transpose plus A. Now the P is equal to the P transpose. So A plus A transpose is a symmetric matrix. Now second one, if P equals to A minus A transpose. Now if we find out the transpose of this matrix, now the now the P transpose is equals to the A minus A transpose whole transpose. Now is equal to the A transpose minus of A transpose whole transpose. So P transpose is equal to the A transpose minus A. So now if I take the minus common, then it is A minus A transpose. So P transpose is equal to the minus of P. So the A minus A transpose is a skew symmetry matrices. Now the third one is, if now again consider the P equals to the A transpose or A transpose. Now if we take the whole transpose of this matrix is now equal to the A transpose of transpose into A transpose. Now I have written this by this statement. Now A into B whole transpose is equals to the B transpose into A transpose. So it is A into A transpose. Now the transpose of the matrix is equals to the A transpose. So A transpose is symmetric. Now let's take the next example. If A and B are symmetric matrix, if A and B are symmetric matrix, then show that AB is symmetric if AB equals to BA. This is A and B commute. Now in this question we need to show the AB is a symmetry matrix if the AB equals to BA. Now let's see in the solution. Now given the AB symmetry, so the AB whole transpose is equal to the AB. AB whole transpose is equals to the AB. Now the meaning of the AB symmetry is, so if we find the AB transpose by the rules, so we can write like as a B transpose into A transpose, and the in the question also given the A and B are also symmetry matrix. So A transpose is equals to A if it is symmetric, or B transpose is equals to the B if it is symmetry matrix. So AB whole transpose is equals to the B into A. So B into A equals to A